Guys, my name is Ernest, and I'd like to welcome each and every one of us to my channel of Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at features of macrocyclic ligands, and these are going to assist us in trying to narrow down to the various types of macrocyclic ligands which we had described, particularly in details from our previous videos on the coordination by macrocyclic ligands. Now, to say that basically in nature, these macrocyclic ligands are going to be described as tetrapyrols, and I've mentioned that basically for the pyrols, these are going to be heterocyclic compounds which we can describe in terms of unsaturated cyclic unsaturated, of course, macrocyclic ligands which are going to be binding to metals to form these specific complexes. And we see that these specific macrocyclic ligands are going to be tetra-dentate given as such, and we see that these are going to be basically describing the coordination that is going to be achieved from ligands that are going to be bind, having four centers that are going to, of course, bind donor atoms to the actual atom at the center to form these specific complexes. And we are given examples of these specific macrocyclic ligands in terms of porphyrin, the chlorine, and the choline. So this is going to be choline. So basically we are given some of the metals which are going to combine with this one to form different types of complexes. For instance, we say that if we have this one having a metal center of iron, then this is going to be forming what we refer to as a hemoglobin, which is going to be found in blood and try to, of course, assist in trying to ensure that the transport of oxygen around the body is going to be facilitated smoothly. So in this case, we talked about this specific concept of chlorine. And if this chlorine is going to consist of a metal center of a magnesium, then therefore this is going to be referred to as a chlorophyll. And this chlorophyll is going to be providing for the synthesis of a food in plants through the process of photosynthesis, which we are going to be seeing shortly in some of our subsequent videos. So in this case, we shall look at the last one, which we said is going to be consisting of a center of course, cobalt. And in this case, this is going to be contained in what we refer to as cobalamin. So this cobalamin is going to be, of course, basically what we refer to as a vitamin 12. So this is going to be, or we shall just have a discussion of this specific, of course, form of this specific complex that's going to be given in terms of vitamin B12. And these are some of the examples which we are going to, of course, be coming across. Now, apart from these specific, of course, combinations which we are going to come across, I've mentioned basically that we can give examples of these organic compounds that are going to consist of these tetrapyrols, of course, units, and this consisted of examples like heme. So I've given just a listed a number of these specific, of course, compounds which are going to consist of these tetrapyrols. Example is heme. So we talked about the example of that one. I've talked about the example of cobalamin, and also we shall look at chlorophyll, which I've just mentioned, and perhaps other examples which we're going to come across in our various discussions. So in this case, these are some of the examples of this specific macrocyclic ligands. And in this case, we shall look at a detailed form of their specific features, or a general way in which we can describe their specific features, which is going to be assisting us try to understand their various types of coordination that we're going to come across. So one of the characteristics that we have mentioned perhaps in our previous video is the concept of kinetic stabilization of this specific complex. So we're going to see that this specific complex are going to be described as kinetically or kinetic stabilization complexes, which are going to be achieved through the various aspects which I'm going to be perhaps describing in a summary form. And the second, of course, feature of this specific macrocyclic ligands is going to be that they are going to be selective in nature. So they are going to be selective depending on the size of this center that's coordinating. Of course, we can just give as a metal center given as such. And as well, we shall look at the third characteristics, which is going to be this specific, they are going to be conjugated by systems. So I described them in one of our videos as aromatic. So therefore, this is one of the characteristics of organic compound, which are going to be aromatic, described as conjugated by systems given as such. And therefore, we can describe them as aromatic. And this is going to be contributing to one of the aspects of internal stability of these ring systems, which I've basically described. Now, the fourth characteristic that we're going to come across for this particular set of macrocyclic ligands is that they are going to be preferring a planar arrangement. And this characteristic basically is not going to be spanning across the various ranges of these specific macrocyclic ligands, but we shall have a few examples and give a reason as to why this specific aspect of a planar arrangement is going to be, of course, one of the unique cases that we're going to be seeing with this specific type of compounds. And lastly, but not least, we can look at an example of these elements being unsaturated, having what we call unsaturated coordination. And being aromatic, we had listed a few characteristics of the concept of aromatic compounds in some of our videos on the concept of aromaticity, and therefore we can see that the third and fifth feature are going to be one of the coherent features of this specific, of course, aromatic compounds, and therefore this is going to be defining one of the characteristics of these macrocyclic ligands. Now, for the kinetic stabilization, I mentioned basically that this is going to be one of the characteristics of these particular complexes, and this is going to be a process of slowing down what we refer to as unwanted kinds of processes, which are going to be achieved through increase of what we refer to as, of course, activation energy. So in this particular complexes, there's going to be a more amount of activation energy that's going to minimize these unwanted types of reactions. And this, of course, is going to be giving them their characteristics of this specific stability that we're describing to us kinetic stabilization. Now, in a sense, this is going to be, of course, one of the characteristics which I've said, and I mentioned about one of the aspects of thermodynamic stability, which we're going to come across in our other videos, that is going to be particularly describing the lowest energy state of various other types of course, these specific compounds that we're going to come across. Now, in a sense, we're also going to see that for selective, they are going to be selective depending on the size of metal ions. Now, I mentioned this one, especially when I was talking about the various types of amino acids and the type of ions they are going to be selectively binding with, and therefore these macrocyclic ligands are also going to be selective depending on the size of a metal center which they are going to be coordinating with. Now, for the the conjugated pi systems, as of course, as I said, this is going to be, of course, going to be giving them one of the characteristics of aromatic compounds, and this is going to be increasing the stability of the ring system, as particularly mentioned. Now, the concept of planar arrangement, which I said basically is going to be achieved depending on the, of course, the presence of this or depending on the kind of stability that's going to be required, and this is going to be particularly the arrangement that is going to be realized in case this specific element is going to, or the compound is going to be rearranging in order to reduce what we refer to as strain, or in case there's a presence of this specific aromatic ligands which are going to be seen as this, then therefore it's going to be, of course, ensuring that this is going to be a planar kind of arrangement. Since this is also one of the characteristics of aromatic compounds which we have mentioned for, particularly this specific feature for 3, 4, 5, which are going to be coherent with aromatic systems. Now, for the last one, as I've said, of course, these are going to be having unsaturated coordinations, especially for the tetrahedral complexes, which is going to be consisting of two axial coordination centers, which are going to be free. Now, if we can just give an example, or perhaps just an illustration of this, of course, kind of course, the geometry. I've mentioned about the octahedral kind of an arrangement. So if we have a metal center that is bound to these specific ligands, perhaps we can give them in terms of n. So we shall have this specific axial coordination points which are going to be given perhaps in terms of x and y. So these specific points are going to be empty sets of this specific, of course, coordination centers, and this is going to be playing a key role, especially for different types of compounds which we can refer to as either enzymes or cofactors, which are going to be assisting in trying to form this specific aspect of a catalyzed form of reaction. So therefore, this is going to be one of the examples of this specific reaction for the macrocyclic ligands that are going to be involved in the formation of this specific coordination that result in what we refer to as phase sites that can be given as such. And this is one of the characteristics of enzymatic activity, which have, or a regulation of enzymatic activities, which I've mentioned in my previous videos. Now, these are some of the characteristics which we are going to come across of particularly these macrocyclic ligands, and they are going to assist us in trying to describe them in case we come across them in our various sets of videos. So that is it for now, guys. Bye, God bless you. Catch us in our next video.